This will be for the con exercise. Calculate conditional probability. So the main formula for conditional probability, this is read as the probability of A given B. Okay, this slash here means given. And what A given B means is that this is the probability of event A occurring given that event B already occurred. Okay, so this formula is going to be the probability of A and B divided by the probability of B. Notice in the denominator, it is divided by the probability of B, which is the one that's given. Okay, so if I were to give an informal formula in the numerator, it's the probability of both, and in the denominator, it's the probability of what is given. All right. So really, this formula here, I just made this up. I put this in my own words, and this helps me remember this formula right here. All right. But this works for conditional probability when one of the probabilities is given. All right. It says Pedro observed what customers ordered at his ice cream shop. Probability of vanilla is 0.3. Probability of ordering a sundae is 0.2. Probability of ordering both is 0.15. Find the probability that a customer ordered vanilla given that they ordered a sundae. All right. So this is probability of vanilla given that they ordered a sundae. So this is the given part. So I'm going to use my informal formula. And that is going to be the probability of both divided by the probability of what is given. All right. So both vanilla and sundae right here, the probability of both was 0.15. That's in my numerator. And the probability of what's given. What was given? The given slash line is here. So it's given that the person ordered a sundae. And that probability is 0.2. Okay. Or you can say 0.20. So if you were to move the decimal over 2 places, 1, 2, 1, 2, that's just a fraction. Okay. And that fraction is going to equal 15 over 20. If they ask us to reduce it, I will do that, okay? But let me test it and find out. See if they take 15 over 20. I know they won't take it as one decimal over another, but maybe if we do 15 over 20, they'll take it. Let's see. Okay, very good. So we didn't even have to reduce the fraction, but you do have to rearrange the decimals. And if you did this on a calculator, it would just be 0.75. So same thing. The usher at a wedding asked each of the 80 guests whether they were a friend of the bride or groom. Here are the results. All right, before we begin, notice that this circle here, if you add these two, that's the friends of the bride. This circle here, if you add these two, that's the friends of the groom. Now, if you look at the ones in the middle, right there, that is the overlap. Okay, that is the people that are friends with both. All right, just for your information. Given that a selected guest is a friend of the groom, find the probability they are a friend of the bride. Once again, I will use my informal formula here. The probability of both divided by the probability of the given. All right, so how many are both friends of the bride and groom? We could see right here the overlap. That's 30. Now, I know 30 is not an actual probability, but you can use the actual numbers as well, and that will work just as well. Probability of the given is the groom. And the groom is this circle right here. So it's going to be 30 plus 20, or 50. All right, so that's it. You can do it on the calculator, or I'm pretty sure they'll take it as is. All right, if I just write 30 out of 50, I know you can reduce that, but I'm pretty sure they take it just like that. Yep, they do. Okay, so probability of friends of the bride given that to friends of the groom, that makes sense. Because you want to find out how many are friends of the bride, but only limiting to the ones that are friends of the groom. You're limited to this. So that's why it's going to be 30 out of 50. That's why the formula works. Researchers surveyed 100 students on which superpower they would like to have. The 2A table below shows the sample students who responded. All right, these are the superpowers, and these are the genders. Given that the student was female, find the probability that the student chose invisibility as their superpower. So, you don't even need the formula really for this one. All right. We want to find the probability of invisibility given that it's female. So it's given that the person is female, and here is the column for female. We are limiting ourselves to this column right here because it's given that the person is a female. And now based on that, what's the probability that the person wanted invisibility? If you trace that across, invisibility in female is going to be 32 out of 48. All right, so that's your answer right there. It's just 32 out of 48. Even if you wanted to use my formula, the probability of both invisibility and female is 32, divided by the probability of the given, the total females is 48. 32 out of 48. Didn't even really need the formula for that one. All right, last one. Vera examined random sample deodorants. Probability for men, probability botanic scent, and men and botanic. All right, so let's use our tried and true formula. That's going to be the probability of both divided by the probability of the given. What's the probability of both men and botanic? That's right here, 0.05. And the probability of the given, this is given that it has a botanic scent. Given botanic, probability of that is 0.18. Don't even need a calculator. Look at the decimals here. Multiply the top by 100, you move the decimal over 2. Multiply the bottom by 100, you move the decimal over 2, and it's just 5 over 18. All right, whatever you do to the numerator, do to the denominator in terms of multiplication or moving the decimal, and that'll work just fine. 5 over 18 or 5/18.